perspective of recent National Academy of Sciences panel assessing the impact of climate change on social and political stress. So I'm beginning with where we are and trying to project forward into this situation. The first thing to say is that I am going to talk out of the context of this panel, but you can't blame the National Academy for what I'm about to say. Just to explain that, the National Academy panel, there were 14 people on the committee and there were 11 reviewers, and all of that 25 people had to agree on the result, which contains a little bit of what you can say. So I'm taking advantage of an individual perspective and extending beyond. And one of the things that and I'll put the geoengineering issue into a broader context, but I will talk about it. One of the things that you feel if you are engaged in any kind of public exercise dealing with climate change at the moment is the pressure of the deniers. And I can tell you the Academy does feel that pressure. It may not be strong within this room, but it is outside. So let me begin by, and the deniers, of course, argue about all the uncertainties involved, and there are considerable uncertainties involved here. But let me begin by emphasizing that there are some things we know as well as we know anything, and they are the radiative forcing effect of the CO2 molecule that's been measured, the atmospheric dwell time, and it was just put on a chart up there, and CO2 concentrations over time. These things we do know. And as a result, what we know is that we are currently adding CO2 to the atmosphere at a rate that is 10 times greater than anything we've observed in the last 400,000 years in the climate record. That 400,000 years, there are possible through the ice core analysis to do annual estimates. Beyond that, going back even deeper, it gets a little fuzzier and not on an annual basis. But you go back to the point at which the Earth was the warmest, and here is the paleoclimate record on the chart. You have a
not that works on that.
A pointer?
No.
Oh, okay. Well, you can see in that red area of the chart is where we hit the thermal maximum. These are deep ocean temperatures. This is 55 million years ago. The process that drove that, just push the red button. Thank you. The process that drove that is estimated, it was part of the sort of plate tectonic. It was 20,000, it was putting carbon dioxide into the atmosphere rate. It was 20,000 times less than what we're currently doing. Now that went on over millions of years to have this effect. But the point is that we're outside the bounds of the paleoclimate record in terms of the speed limit, if you will. And we know that. It is important, I think, sobering to note that the current sea levels are lower than the obvious historic reference points. If you go back onto this chart, and I'll figure this out. This is the top area is the entire record, and then the middle one is a breakout of this part of the chart, and then this is a breakout of that part. This is the Amian period, 130,000 to 130,000 years ago, where deep ocean temperatures were virtually the same as they currently are. Sea levels were 4 to 6 meters higher during the Amian period. And if you go back to the Pliocene period, which is here several million years ago, you get deep ocean temperatures that are only a degree warmer than we currently are, and we're very likely to hit that at some point. And sea levels are 25 meters higher than they currently are. What does that mean? Well, we know that the impulse that we're giving, thermal impulse that we're giving to the atmosphere, will have to be balanced in some fashion. This is basic physics. So either the sea level rise will be more rapid than currently projected, and possibly at a nonlinear rate, or some combination of processes that we do not yet understand. And what that means, and what the Academy panel did conclude, is that means the consequences will be very substantial, probably unprecedented, but unfortunately, that's what scientists tell me. We know that we're dealing with a very large event. We cannot tell you the time, magnitude, character, even, or location of the consequences with the kind of precision needed to inform, if you will, policy actions. This is kind of a graphic demonstration of that, and has already been alluded to. This is the chart of Arctic sea ice. And here you see this line is the average of all the climate models. And the gray area, I think, is the 3 sigma line, variation around that line. And the climate models, of course, are using the equations we know, and they are trying to project on that basis. And this is the actual experience. We're way outside the bounds of the climate, and that is alarming. The climate scientists, they do not know how to account for this. They're observing, in this case, a rate of change much more rapidly than anybody knows how to take into account. In this situation, looking at the policy consequences, if you will, decisive mitigation is technically feasible. Armin sort of took us through it. You can do these things, but we're not currently doing them, and you cannot presume that over the next several decades we are going to get effective mitigation. And therefore, we have to anticipate extraordinarily severe burdens of adaptation occurring with increasing frequency and severity over the next 3 decades. Human societies as a whole are going to be under increasingly severe adaptation pressure, and some of them are not going to handle them very well at all. And let me take you, in the course of this Academy report, we tried to identify those parts of the world that looked like they were most vulnerable, and of course we could not get consensus on this, but let me tell you that Pakistan is a pretty good candidate. It is an internally fragile society. It has a very prominent agricultural sector. It is highly dependent upon hydrology in the Indus River watershed. 30 to 40% of the river flow derives from glacier and snowmelt. And they're facing sharp allocational trade-offs within Pakistan, pitting irrigation versus power generation, which is hydroelectric, and irrigation across provinces. They're using very divisive water allocation rules. They're favoring irrigation over power generation, basically, because of the politics of the country. They're favoring the Punjab, which is over the Sindh, although the Sindh is much more arid. And the whole allocation process is based upon unrealistically high estimates of availability. And they're thereby creating divisions of interest between industry, dependent on power generation, and believe me, the whole future of the Pakistan economy depends upon the generation of small and medium enterprises who are dependent upon power. They're pitting that industry against agriculture, depending on irrigation, and urban areas depending on water services. In that situation, and for whatever reason, it turns out that their burdens are being intensified by one of the more troublesome climate phenomena going on. And without trying to go through the technical details of it, basically what's going on is that there is accumulation of the Karakoram glaciers north of Pakistan at high altitudes, and recession of the glaciers at low altitudes, resulting in a 30% reduction in the Indus River water flow. It's a global anomaly, a phenomenon generated by climate. In addition to that, which is not a global anomaly, but it's one of the locations, they're getting increasing precipitation in some some areas and increasing drought in others, and the ambient temperatures are affecting their agricultural product cycles. In this situation, this is what I really thought. We're already generating pretty much chronic violence within Pakistan on a daily, almost daily, certainly weekly basis, associated with particularly power generation. Most of the Pakistan villages go without power for 16 hours a day, something of that sort. And they are getting riots associated with this. And just to sort of add a little chilling evidence, the Taliban has discovered that that you can induce people to attack the power stations in frustration against the cutoff, which of course worsens the problem. And they have discovered that that's a much more attractive way of mobilizing political support than even sort of attacking the United States. In other words, the power stations are more unpopular than we are. This is serious trouble in a serious place, and it is being driven in a very meaningful way by a climate anomaly that the government is not able to handle given the structure. And that's the basic message that we're trying to convey in this Academy report, is that we're looking at not only climate change, we're looking at social stress associated with that. These things are going to interact, and we're likely to have significant trouble in some places. What are the global security implications then of this situation? I think we have to anticipate adaptation failures in some societies, severe enough to induce international reaction of unprecedented magnitude, and we're not prepared for that. At the moment, we're getting a lot of warning in Pakistan. We're doing nothing about it because we don't know how to read it or react to it. We must prepare, as Jason has just told us, to manage geoengineering contingencies because they are going to be increasingly debated and tempted under these circumstances. And then ultimately, I'm picking up on what Armin was saying, we have to anticipate eventually a compelling global mitigation effort. As it gets worse, as it will, our societies are going to, first of all, have to accept the global warming phenomenon and the danger associated with it, and are going to have to take the problem of mitigation far more seriously than they currently do. Okay, so if you believe that, then what do you do in the short term? Immediate practical steps. First, I would argue, and that's what the Academy report argues, that we have to develop a global monitoring system worthy of the problem. We need to monitor not only climate variables, but social vulnerability variables systematically and at high resolution. And again, we can do it, but we're not doing that yet. We're not doing anything like the degree of monitoring that we could do. So we're arguing that we need to integrate our intelligence community assets with the Global Climate Change Research Program, initiate a diplomatic process to assure global collaboration on it, and establish a continuously managed database to prioritize climate and social indicators. And just to give that a little sort of less abstract. At the moment, it's clear that South Asia is one of the critical areas we need to look at. India does not allow us to have the water monitoring station data. Why? Well, they want to sell it. And I asked, well, how much would it cost? Well, $5,000. That doesn't seem like, but the principle is a problem. So NOAA, which would love to have the data, cannot buy it because they don't have either the money in their budget to do this, and they are unwilling to accept the principle of buying data. Pakistan classifies water flow data. And these are just in these two critical areas. As a result, our monitoring is based entirely upon satellite observation, and we're not sustaining the satellite system that is currently doing that. We're going to have to get better at monitoring. And we're arguing in this report that not only do you gather the data, but you do periodic stress testing in critical areas to try to pick up situations and observe situations like what's going on in Pakistan before they really blow up. In addition, picking up on what Jason said, and not at all trying to solve this problem, but just emphasize the importance of it, we're going to have to establish protocols for global vetting of solar radiation management in field trials and ultimate approval of any solar radiation management operation. He described, I think, the principal technique that we do know would work because the volcanoes do it. There are several countries that are capable of conducting that operation within their own airspace. So putting the particles, sulfate particles into the stratosphere without ever leaving their own sovereign territory. Some of those who are subjected to severe adaptation problems are going to be tempted to consider solar radiation and are going to be tempted to argue supreme national interest. But we can be very, very sure that the world as a whole is going to quickly discover, if they're not already aware, supreme global interest in maintaining the integrity of the atmosphere. The consultation and review procedures at the moment are embryonic and cannot expect it to carry the burden of proof. So the things that Jason is talking about, we're going to have to worry about. We're going to have to develop then, with mitigation ultimately in mind, prototypes of small modular reactors with passively safe and zero fuel features so that we can expand nuclear power safely, both in terms of operationally and in terms of proliferation. There are several designs that are promising, but none of them are being developed through the prototype stage, the famous Valley of Death at the moment. The money is not available to do that because nobody sees, nobody is going to take that on. And finally, then we're going to have to develop, with that in mind, an institutional design for the global management of nuclear reactor production and fuel cycle services. If we're going to expand nuclear power, which we have to, if we're going to do mitigation, we're going to have to do it at higher standards of operational safety and lower standards of proliferation risk than we're currently doing, or we're going to make it worse. And then finally, as we go through a mitigation transformation, we should realize we're going to have to transform the security relationships among the critical players, the US, the EU, Russia, China, India, to allow the degree of intimate collaboration that's going to be required to accomplish mitigation and to subordinate what at the moment are sort of the military confrontation that goes on in these societies. In general, the argument is that the social effects of climate change, because of the consequence of it, will be as extensive and as consequential as the ecological effects. In principle, they can be constructively shaped, so you can say this is constructive opportunity. Surmountable danger offers constructive opportunity. However, it remains to be seen, I'm afraid, how it is actually going to work out. It's probably easier to be pessimistic than optimistic, but we can say that human societies are facing an unprecedented challenge here. And either they're going to rise to the occasion or they're going to be very severely damaged.